All right, it's two after. Dan, you want me to go ahead and get started?
Yeah. Yeah. Just thanks everybody for joining us tonight. Before Matt gets into it, I'm Dan Sheridan. I'm with Montgomery County Department of Transportation, and we're here to talk about the River Falls drainage issues.
All right. Yep. Like Dan said, we're here to talk about the preliminary engineering design phase. As probably a lot of you know and have participated in the past, we've already gone through a couple previous meetings before and after our study that we did on the storm drain system and drainage in the neighborhood. So this is a continuation of that same project. We're gonna be this phase is gonna be our initial engineering and design. So uh, just a couple housekeeping things here. So everybody's microphones have been muted and cameras have been turned off. Please don't turn on your mic or your camera during the meeting. Um, just save on bandwidth and also to avoid interruption for everybody. There's going to be a question and answer afterwards. Please wait until the end to raise your hand, and then you can also put your question in the chat box. We'll try to get to as many questions as we can um, at the end. To raise your hand following the presentation, you can click the reactions icon at the bottom of your screen and then click raise hand. If you're calling in, you can press *9 to raise your hand and *6 to unmute. Like I said, we will be reserving all questions until the end of the presentation. Quick overview of what we're going to be going over tonight. We're going to give introductions to the key people involved in the project, a little bit of an organizational and project organizing overview, a little bit of background that some of you may have already seen, but we're going to go over a little bit to remind everybody about the flooding issues and what's already been done in the neighborhood, some completed projects that we've already undertaken, the scope of the next phase of the work, the schedule, and then we'll go on to our questions. Um, so this meeting is an overview meeting. We're going to go over the project structure, what it's about, what we're going to be doing, the schedule. We're going to not be answering specific questions about specific issues. I know a lot of you have specific concerns around your residents or specific flooding areas that you want addressed. We've already received a lot of input from you, a lot of emails. We are working diligently to respond to all of those. But we're going to try and limit our discussion tonight as much as possible to the general structure of this and address everybody's individual issues separately. So if we could try to limit our questions and discussion to the general project or general concerns, that would be great. Depending on how much time we have left, I know if everybody chimes in on individual stuff, we just won't have enough time. But we will get to everybody. So if you have a specific question or concern or comment, you can go to the project website, which is there below, and click on the participate tab. And my email is there. You can email me, you can email Lori, or you can put it in the comments section, and we will try to get to all of those as we move forward with the project. So some key introductions. This is all under the Department of Transportation for Montgomery County. We are with the Division of Transportation Engineering, which does most of the design work for the Department of Transportation and construction of new facilities like storm drains and things like that. This is undertaken by the team that's the Drainage Assistance Request Program. This is a program that looks at drainage issues throughout the county and comes up with solutions. Key personnel. So Dan's already introduced himself. He is the DTE Design Section Chief. Kyle Hanley, many of you may have met him. He is the Drainage Assistance Request Program Project Manager. I am Matt Spielman. I am the in-house drainage consultant. I take care of most of the incoming calls and reports, and I manage the cases that come in and kind of shepherd each individual case through the evaluation and construction. And then Bill Park, who's here, is the program consultant and the engineering services manager. So he oversees all of the engineering and design for these projects. I want to do a special thanks to Lori. Lori is not technically with our program, but she has helped us a lot with getting these meetings set up and answering questions. So thank you very much, Lori. Quick what I was talking about. So this is kind of the organization. So obviously DOT falls under the Montgomery County Executive. All the funding for DOT and its projects come from the county council. They are the ones who assign the funding. Transportation engineering is then a division within Department of Transportation. So we have a number of different CIPs. These are capital improvement projects. This is how money is assigned to these various projects by the county that cover the different projects. So this upcoming preliminary engineering is going to be funded out of existing storm drain um, design funding sources. So we've got three that doesn't really matter. Each one does a little bit something different, but we are going to be funding this out of those three different CIPs. The final design that's going to be coming up following the preliminary design is already funded, so there's a separate CIP for that. So the final design, which will be happening next year, as a funding source. However, the construction is going to be the funding for the construction will be determined after we complete the final design. The cost estimates that we come up with in final design will then be sent to the county council, and the county council will evaluate them for funding. These CIPs always go up against all different CIPs within the county. It's going to depend on the county budget at the time. So just letting everyone know that construction funding still has to be decided, but we will be able to get completely through design with existing funding. Just a quick overview, and I think a lot of you've seen this before, but we're going to talk a lot about return periods. And this is, you'll have heard probably the 10-year storm. Essentially, what this means is a probabilistic model. What we're looking at here is a 10-year storm is considered to be a storm that has a rainfall intensity that happens about every 10 years, or there's a 10% chance of it happening in any individual year. And if anybody has worked with probabilities before, you know that 10% does not mean that it only happens once every 10 years, that you could have it happen several times in the same year, several every year, and it would not necessarily violate probability. Obviously, if that continues over a long period of time, the model needs to be reevaluated, but it's not something that you should only necessarily expect to happen every 10 years. The same applies for all the different types of storms. So the 100-year storm has a 1% chance every year, and then the 1,000-year storm has a 0.1% chance. These probabilities are based on past observational records, so normal rainfall that you've seen at a particular location. They are updated periodically as newer information is gathered. The model storm is a 24-hour storm, so this is looking at rainfall over a 24-hour period. Extremely heavy storms that dump a lot of rain, a lot of inches within a very small amount of time, may possibly not even meet a 10-year criteria over the 24-hour period, but in actual terms of the capacity of the storm drain system may exceed the 100, 1,000, or even 10,000-year storm, depending. Within the last 10 years or so, we've had at least 5 extremely heavy storms that have been very short in duration. A lot of water has fallen. Several of these have caused significant flooding within the neighborhood, and that is why we are here doing this work. So the drainage systems are designed for a specific return period. So most storm drain systems throughout the area, especially, but even nationwide and in other countries, are designed for the 10-year design storm. Certain things like larger culverts or major arterial highways may have a different standard, but 10 years is pretty common for all residential storm drain systems. Building a new system is definitely easier than upgrading an existing system. So these 10-year storm drain design standards are really for any new construction. Any new storm drain going in the ground have to meet these conditions. Standards change over time, and the way things are calculated changes over time. There are quite a few storm drain systems throughout the county that don't meet the technical 10-year as our current design standards are. So anything new has to be designed to those standards, but there is currently no requirement or funding to upgrade all the systems throughout the county to these standards. Now, this project, we're going to attempt to get ourselves up to the 10-year in our designs as much as we can, focusing primarily on flooded areas. We want to make sure that the flooded areas see the most relief. If there are areas that don't necessarily have bad flooding, or the flooding is not particularly affecting property or safety, it may not necessarily be the case that we would need to upgrade that to a 10-year. It may also be counterproductive if we aren't able to get parts of the system that we need up there. Retaining that water in a safe manner somewhere upstream may be the desirable option. As far as the future of the design standard, the county is, amongst other things, considering changing the rainfall values for the 10-year storm, or potentially changing the design standards for the county, but that has not been decided yet. We are currently working under previous 10-year design standards. If you would like to know more about what the county is doing for in the future, looking at flooding, looking at potential changes to the standards, you can go to the website for the comprehensive flood management plan being done by the Jacobs consultant. A lot of information there about how the county is looking at flooding in the future. So in this neighborhood, I'm sure a lot of you experienced, there have been several significant storms, particularly back in 2019 and 2021. Coach Street, Stable Lane, places up on Hackamore and River Falls. A lot of these places had very severe flooding of the streets, of the homes. These were extremely large storms. Again, most of the rain was dumped within about half an hour to an hour. But if we extrapolate that out to a 24-hour period, a lot of them were technically, or at least by design, exceeding the 1,000 or the 200-year storm period. So, as many of you may know, one of the big issues in this neighborhood is the problem of piping streams. So, in the past, a lot of design was done where they would remove streams that were pre-existing to build a neighborhood. They would pipe them through a storm drain system instead of letting them stay open streams. Natural streams have very wide flood banks. They have places where the water can overflow and safely soak in or be retained and then trickle out. The pipe systems, they handle the base flow and storms up to whatever the design standard are, but those larger storms now lack their floodplain. And then the floodplain becomes essentially what was above the previous stream. So in this neighborhood, we've got two different locations where streams were piped. In the north, across those places like Coach Street and Hackamore, Horseshoe, there used to be a stream as shown on the original plan that flowed through the neighborhood here. And now the storm drain has piped that stream through these streets, and there are houses over what used to be the floodplain. The outfall from this is located on down there at the end. It is a 72-inch pipe. This is essentially what the stream has become. Same thing in the south. A stream used to run through down where there's a current conservation area, and then across a Stable Lane and down eventually into the Potomac. They've now piped this stream at two different locations, with some of the historic stream remaining within that conservation area. This has a 66-inch pipe, so again, this is now what the stream has become within the pipe. So as part of our storm drain analysis, which can be seen online at the River Falls website, you can go through the entire report. We located a variety of places within the neighborhood that are at risk of flooding due to the lack of overland escape for the water. The only way for the water to get out is through the storm drain system. So any storm exceeding the storm drain system design capacity is going to fill up within these areas. So obviously in the upper part of the neighborhood, Hackamore, River Falls, Coach, these are all particularly problematic areas where water can flood. Same thing in the lower area, Stable Lane, MacArthur Boulevard, the area behind MacArthur Boulevard is particularly in a flood risk. There are other areas throughout the neighborhood, but those are the primary areas of problems because that's where the stream flows. We have completed two projects in the lower part of the drainage area to attempt to alleviate some of the flooding, one at Stable Lane and the other at the MacArthur Boulevard culvert. So the completed project at Stable Lane, we realigned a small section of the pipe at the road to reduce a drop that was causing some clogging issues. And then we improved the pipe head wall and part of the stream near the head wall to improve inlet efficiency. This particular project was done within an existing maintenance easement. The entire stream does not have this maintenance easement. I know a lot of people in the neighborhood have concerns about the maintenance of that natural forest conservation area, but DOT has limited easement within that. For the rest of it, it's private property. So we did some work where we could, but most of that is outside of MCDOT jurisdiction. The other one that we completed was the MacArthur Boulevard culvert. We excavated the interior of this, removed a lot of built-up sediment over time. You can see how much was filling up that culvert there. So this is owned by U.S. Army Corps of Engineers because of the DC aqueduct, but MCDOT has taken on maintenance of the storm systems involved associated with the road, and so we undertook this culvert cleaning. So moving forward, we've already done the study, which again you can see online. What we are now going to do is take that information and come up with a engineering design to attempt to alleviate flooding in the neighborhood and upgrade the system to the 10-year where possible. So the stages of this are going to be field data collection. We've already begun this. There's going to be topographic survey where we don't already have it around the existing storm drain system or anywhere that we've identified for upgrades. This is going to give us needed elevations and other information about the area so that we can plan our design. Utility designation, which is going to be very important. There are a lot of utilities that run through this neighborhood to service the houses. We have to work with those utilities, work around those utilities, or potentially relocate those utilities, which we'll talk about a little bit later. And then we're going to have to be doing environmental impact assessments. We've got to look at what our project is going to do as far as impacting the environment, trees, the downstream streams, the streams in the neighborhood. So once we get all that data collected, we'll move on to the design phase. The design phase, we're going to come up with some alternatives to present to MCDOT about different ways that we can potentially make improvements in the various parts of the neighborhood, both in places that are affected and places that are not, to try and retain some of this water or get it through faster or get it away from houses to prevent damage. There's going to be some H&H report, hydrology and hydraulics reports, just looking at how the system is functioning and how we can upgrade it. And then we're going to be giving the county cost estimates on for the various options to try to present to the council for construction funding. And then we'll get to our final concept selection that will be presented to the council. So we're going to be looking at potentially a few different ways to control flooding within the neighborhood. So the most obvious would be capacity increase. This is just straight up pipe replacement, making the pipes bigger, making the inlets bigger. So increasing the size of the existing system. Other options then would be to storage. So we can try and withhold some of that water for longer periods of time in various parts of the neighborhood so that it drains more slowly instead of quickly accumulating within these flood areas. A couple ways to do that would be what we call BMPs, or best management practices. These are bioswales, bioretentions, grass swales, places that can provide both filtration of the water, but also some storage and some infiltration into the ground. So it will not only hold the water back in the facility, but allow some of it to drain into the ground where it can enter into the groundwater. A couple other storage options would be stream daylighting. We'll talk about that a little bit later. And then underground storage, was essentially building cavities underground where the water can accumulate and then drain out slowly over time. And then finally, we'll be looking at mitigation. This is essentially what can we do in the neighborhood to design ways that if flooding occurs, if we were not able to prevent it, to safely get it out of the neighborhood or safely get it to a place where it's not going to cause as much damage or any damage. Again, won't be stopping the flooding, but putting the flooding somewhere where it's not going to be causing the damage. So the pipe replacement option, pretty straightforward. We dig up the pipe, we put in a new bigger pipe. Part of our design was our pipe capacity analysis, looking at areas throughout the neighborhood that currently do not meet the criteria for the 10-year storm. We found various pipes in the upper and the lower drainage area that don't meet the 10-year storm. One thing is that a lot of these pipes may be only slightly undersized, so we may be near the 10-year storm, and maybe it's a 9.5-year storm. So what we're really going to be focusing on are those heavily flooded areas or areas where the pipe is significantly under capacity. If we Some of those areas with the slightly undersized pipes, if that area is not actually flooding, it may be better for us to just leave it as it is. The smaller pipe will allow some of that water to be held upstream in a place where we've already determined that it is safely held and prevent it from being more quickly sent down into an area that's already flooding. One easy way to increase drainage from the roadways is just inlet upgrades. A lot of inlets are not necessarily meeting the 10-year storm. We can upgrade these inlets just by widening them. Obviously, for safety purposes, they have a limited height. We don't want kids and things being able to climb into them, but widening them out will allow more water to enter that system. One potential issue with the inlets is that it's going to be dependent on the storm drain pipe capacity itself. If we upgrade the inlet, if the pipe can't handle it, then that's not really going to help us out. So it's going to be part of a larger upgrade plan. The retention, the bioswale bioretention, you may have seen these around the county. The county tries to do these as much as possible. We are mandated by the EPA and by MDE to treat stormwater in the county through the county's MS4 permit process. So these are natural systems that we design that will have plants and will have infiltration media, allowing water to soak into the ground and to be uptaken by the plants, removing pollutants and sediments from the water. They also have a storage capacity in the above ground portion particularly, but also within the media that's very porous. And they also allow infiltration, which gets some of that water into the ground. We've already identified quite a few locations within the neighborhood that would be ideal for BMPs. As part of this design process, we'll be then looking at these after our surveys to determine which ones are the best locations and will give us the best bang for the buck. Another way that we can do some storage and some infiltration is grass swales. So this is essentially just a channel, a wide bottom channel along the street. In the upper parts of the neighborhood, these are already existing. But what we may be able to do is to widen these, to expand them, and this will allow more water to infiltrate, slow the water down, and we're going to be able to create some storage in there for retention to slow down the water coming into the system. These are the locations that we've so far looked at for potential grass swale improvements. This is going to be limited to what we call open section areas. These are areas without the curbing where we already have roadside drainage through some kind of existing swale. We'll just be able to expand those. The nice things about the grass swales is that they're essentially just an extension of lawn, so they can be mowed like any other part of the lawn. And again, most of these are already pre-existing swales. It would just be the expansion of the swale for more capacity. One thing we will be looking at is if there's anywhere in this neighborhood that we can do stream daylighting. The most obvious place would be around the community center. There is a piped piece of the stream there that's within a grassy field. We might be able to do some kind of a daylighting there. The big benefits of the daylighting is that it creates a massive amount of storage. So we'll be able to both increase capacity by just the stream channel itself being much bigger than the existing pipe, but also create a type of constructed floodplain around the stream that would allow the water to safely accumulate within the floodplain and store it instead of flooding in the streets. This is the one location where we would potentially be able to do it. Again, none of this is decided, but this will be part of our potential recommendations for the daylighting of the stream and then the floodplain improvement. You can see here the existing ground is dashed there, so it would be quite a bit of lowering of the existing ground to provide a big area of storage. And then this part of the stream in particular does have base flow. A lot of people are concerned about bugs and mosquitoes, but most streams in the natural environment are actually very beneficial. The mosquitoes that breed there are not the type that carry disease. It's difficult for mosquitoes to breed as well because these flowing streams breed a lot of predators that will eat the larvae and the mosquitoes themselves. If you want more information about mosquitoes and streams in the natural environment, you can go to the excuse me, um, DEP website. They've got some information on that link below. Underground storage. So this is essentially putting a cavity into the ground, usually made out of concrete. Sometimes you can do it with pervious egg crate type plastic structures. These essentially just hold water in the ground. Nice thing about them is they are not visible. The big issue with them is that they are quite expensive to install. So if we can find any locations for this, we might consider this option, but it will be a bit costly, but it might be one of the tools in the toolbox we can use. And then one idea that we're looking at as far as mitigation goes is sidewalk lowering. So there's several sections of sidewalk within the upper neighborhood, part of the neighborhood that we've had a lot of issues with the water flowing down between the flooded streets. One thing we're going to attempt to consider is to actually lower these sidewalks and create a safe channel for water to run between the houses. Right now, the water has already done this a couple times, except the sidewalks are fairly high and uneven, so it's not evenly distributed and it flows off onto the surrounding properties. They're also somewhat higher than the road, creating a backup condition before they overflow. What we're going to try and look at is if there's a way that we can lower these sidewalks and create essentially an overflow channel to bring the water downstream and relieve the street flooding. These are the three sections that we were talking about. I know there's been a lot of flooding issues around these sidewalks, so that will be a key area that we are going to look at. And you can see here the sidewalk kind of rises and then drops down again. It's not particularly even. What we would essentially do is flatten out that slope, lower it down to near street level so that if the street starts to flood, it's going to flow through there safely instead of accumulating in the street or flowing off onto the surrounding properties. Again, this is all going to be online, so if you can go back and look at these. These are just some pros and cons of everything. So grass swales, they're simple, eco-friendly. They provide good storage and they're mowable. The big con is we're going to be limited where we can put them. It's going to have to be in places where they essentially already exist, places without curb where the water flows off the side of the road. Inlet upgrades, like I said earlier, easy to construct. They're easy way to get more water into the system to try to clear out the street, but you're limited by the pipe capacity. So if you don't have corresponding pipe upgrades or if the pipe is undersized, it's not going to help you out. BMPs, these are great. I mean, they're eco-friendly. They store water, they infiltrate water, and they increase water quality. So we love these. Problem is they tend to need to be large to provide a lot of benefit, and that also increases their cost. So they are also above ground. So they are seen. Some people like them, some people don't, but we like to use it as much as we can. The sidewalk lowering, again, we could potentially significantly reduce the flooding of the roadway and the surrounding properties. Issue with that is it's really only going to be the mitigation. It's going to be during the floods because it won't do anything during a standard storm. If the storm drain system capacity is working for the storm, it's not going to do anything. It's really just for those really, really heavy storms. Pipe upgrades, again, we can increase the speed of the drainage out, but we're going to be space limited, and especially in some of those tight right-of-way areas. We've got utilities that we're next to, and the bigger you make the pipe, the more expensive it is to put in the ground. And as you get bigger, they just get very, very expensive to put bigger pipes in. Underground storage. I mean, the best thing about them is that you don't see them. They're underground, but they are extremely expensive. And because they have to be so big, same issue with utilities and available space. So they can only be so big. And if you can't make them big, you don't get very much storage. And then the stream daylining, this is by far, the most amount of storage. I mean, it's just a massive amount of surface storage, but it's very eco-friendly. It's very natural. You get a lot of biodiversity. You get a lot of good insects, things like that, birds. But it can be very expensive, and then you will lose some use of the existing land that the stream restoration goes through. So the major hurdles of all of this is going to be two key areas. So available space. So we're pretty much going to be limited to the county's right of ways. So this is the roadway right of way plus the shoulder off the side. the right of ways between the houses where the existing storm drains and utilities runs, and then any existing storm drain easements that the county has for existing structures. Obtaining any new property or easements is an extremely lengthy and expensive process, and it has to be approved by the landowners. So we are going to attempt to do as little of that as possible. It is an option, but it really needs to be avoided wherever possible. The other thing is utilities. There are a lot of utilities. So sanitary sewer, water, electric, gas, telecom, and fiber all run through this neighborhood pretty much along every single street. Most utilities require vertical and horizontal offsets. So we can't be within a certain distance above or below the utility. And we can't be within a certain distance horizontally from the utility. If and now the county has most of the time what we call prior rights. So we can get the utilities to move the utilities if we request it. However, we still have to locate, test pit, and tell the utility companies where we need them to move it. And all relocation is done on the utilities company schedule. So that can significantly increase the time frame for a project to have to do utilities, plus all the coordination and design. So, and then in some cases, there just may not be any way to fit a larger storm drain or a facility within the existing utility structure, and there's a limit to how much we can move utilities. At some point, it just becomes not feasible to work around them. So that's going to be a significant driver of where things get put and how big things can be. Just as a small example, just that very small section of pipe that we replaced down on Stable Lane had a ton of utilities. So this had gas and water and telecom and electric. You can see here on the left-hand side, all of those lines indicate utilities running by the project area. And on the right-hand side, you can see those colored dots. Those are where all the utilities were located next to the structures that we were working with. So we did end up actually having to have Washington Gas relocate the gas line. Luckily, that was the only utility we had to move, but that still did set us back in time frame until they were able to get that done. The more utilities you have to move, the longer it's going to take. So the upcoming schedule. So like I said, we've already begun the field data collection process. That's going to be going probably about through January. In January, we're going to start having enough information where we can begin the design. We are going to work through that. And then in sometime around April, we're probably going to have another community meeting, go over the design as we've come up with, make sure that we've addressed as many people's concerns as we can. Again, within that time, we'll be working through all the comments that you've been sending in, giving you responses and incorporating those things into the design where possible. So we'll talk to the community then and get everybody's input again on the design and where things are going, and if anybody's missed or if anybody has additional concerns. And then once we finish up that design phase, we'll go into concept selection in May. So we'll essentially have internal meetings, make sure that we internally decide, which options we're going to go with. And then we will begin the final design phase in June of next year for the final design for the county council. Just a few things here. We've gone over this before, but everybody can help as far as flooding goes. We're undertaking this project. We're going to try to do as much as we can. We're going to try and relieve as much flooding as we can. But the county is growing and land is being developed, and even if it's not a new house, you've still got people. People put in patios, people put in sheds, people put in impervious surfaces that create more runoff, and all of this accumulates and can increase the risk of flooding. So everybody can assist with reducing impervious and reducing runoff on their own properties. So putting things like rain gardens and dry wells and rain barrels, every little bit helps. The more that everyone does, the more it helps. Each individual property can only do so much, but if everybody does it, we can actually significantly reduce the amount of water. So I would suggest going to the Rainscapes program website. There's a lot of information on there on what you can do on your own property to help reduce runoff from your property, and they even offer some financial assistance. And then preparedness. This process is still going to take a while to finish. Even when it's done, we are not going to be able to account for every single storm. Those really, really heavy storms that we saw in the past couple of years are still going to significantly exceed the design capacity of the storm drain system, no matter what we design it to. So, there's always going to be a risk of flooding. We hope to reduce it as much as we possibly can, but I still recommend that everybody make use of the public information available and the public services available for flooding. The state and the county all have these various services where they can help you out with that. So that's all I have. I guess now we can, Lori, we can open it up to questions.
Okay, we actually have a sign up for comments. So first, we're going to hear from Eugene Ebner.
Can you hear me?
We
Yes.
can.
Yes.
Okay, thank you. Thank you very much for taking the time to provide us with this briefing. It's really greatly appreciated. My question is, once the final engineering design is completed and approved and the final cost of the project is identified, how will the county establish priorities for funding this effort? For example, are quantitative standards such as a cost benefit ratio used and/or are other qualitative standards used? And if so, what are they and where are they all published so that we can review them?
We can definitely do a cost benefit. We do that with our storm drain projects. Uh, we can look at a cost benefit ratio, and then the just the design standard, as Matt mentioned, is for storm drains is the 10-year standard.
Dan, I think his question was, how does the council, I
Oh,
guess we may not know that, but how does the council determine priority for their funding for
oh,
these CIP projects?
well, they have there's a wide range of projects that they have to fund, but they're just like that. They're we could in our cost benefit we can analyze number of properties, reduced impacts, and things like that. They may ask for that as a guiding thing, but I don't specifically all in general the Department of Transportation, all their projects and budgets are competing, for every, transportation dollar there is. So,
And Mr. Ebner, if you send us an email or a comment about that, we will see if we can find you some documents from the council about their CIP process.
Okay, next we'll hear from Ted Duncan. Mr. Duncan, can you unmute yourself? Okay, we will come back to him. How about Edward and Jill Feldman?
Well, good evening. Thank you all so much for this. Can I be heard?
yes, we can hear you.
Okay, so basically what I'm hearing is that the county approved development on a floodplain with what I heard was an outdated drainage solution to the area. Does the county hold the developer responsible for the development in any way to regroup some of the costs?
So when this development was constructed, the standards were different. They probably did not. I'm not even sure they had the 100-year floodplain system at that time. Even if they did, they probably did not require a study on the stream that small.
Mhm.
So, and there is definitely a difference between a floodplain in general and then the FEMA floodplain. The FEMA floodplain is a very specific type of 100-year floodplain that's done through a special kind of delineation. But every stream has some kind of a floodplain associated with it, which is kind of what we were getting at. But the the design at the time met the standard of the time, but those have changed, and also rainfall intensity data has changed over time. So I think that I would say that it was designed to a certain standard, and now we've changed those standards, and we don't consider it to be necessarily what we would build anymore. But we're trying our best, since we do have flooding in this neighborhood, to bring it at least up to current standards, and relieve some of that flooding.
So that's the other thing. If there are certain standards, what I'm hearing is it will be dependent on the budget and depending on what's happening in the rest of the county. So there's a good chance that this will be a band-aid and not fix the problem. Because if we need larger pipes, I don't understand why we're not just getting the larger pipes. I mean, a substantial amount of damage was done to our neighborhood.
Correct, but I guess a couple things. Larger pipes aren't always necessarily the best option.
Well, I'm not an engineer. I don't know.
Yeah, but so
I just
the
want it. I don't want the Band-Aid, thrown at us versus here's what has to be done to resolve it. Let's spend the money and do it.
Well, again, the resolution. So we're going to try to get this up to the 10-year, which is our current 10-year design standard. But these storms that we saw exceeded even that standard. So
Right.
there is currently no. I mean, the county does not require anything above that. Even if we went to the 25 or the 50, 50-year storms, it might not necessarily have stopped that flooding. The question would become, how far do you go? Do you design every storm drain system for 100-year, 1,000-year type of thing? And
Matt, can I?
Yeah, go ahead.
Yeah, so I think that's right. So, and Matt alluded to some of these options, like could provide some overland relief in a very large storm. So again, we're going to be kind of surgical about it because there isn't an unlimited amount of funding. So we know there are certain areas that have flooded in large storms. We're trying to go after addressing those areas in a surgical way, and perhaps and also looking at providing some overland relief in a larger flood. So try to do both if possible.
I understand that. I understand also there was a very unusual environmental situation with the rain not being blown off, but I hear that's becoming much more common these days. So I don't know if it's going to be taken into consideration. I mean, my only concern is that while I appreciate everybody's effort, a Band-Aid, I don't know what this means because I'm not a land engineer, but a Band-Aid may not solve anything. But I guess we have to see what is the timing in conclusion for the report to be done so that we can review this and know when the work will start.
So we're going to work on the preliminary engineering concepts and come back to you guys in the spring, late spring, with some options, and then final design will come in the following year. So if it's all completed design by the end of our fiscal year 26 and funding is provided for construction, it depends on when that construction funding is provided, but currently it's only funded for design. The idea is that we'll get better cost estimates in the spring and summer to be able to put that in front of the council so that they can decide, when they can afford to do the next step of construction. But it would be no earlier than the summer of 2026.
All right. Well, we thank you so much for all your work and for all you do for Montgomery County.
Sure. And I don't think we answered your question, but I don't think there's any way to go after the original developer. Again, as Matt alluded to, that at the
he
time
met the standards, I guess, at the time.
Correct. And then, it's also a long time ago. So even if that entity even exists, I don't know.
Well, if it starts raining, can I come to your house, Dan?
Yeah. Get there before it starts raining.
All right. Thank you, guys.
Yeah.
Thank you.
Laura, you're muted if you're talking, sorry.
Sorry, guys. Next, we'll hear from John Miller.
Hello.
We can hear you.
Hello.
Hi, we're on Coach Street, and I thought some of the ideas of lowering the sidewalk was terrific. Of course, then where does it go? But watching the flood occur with us was, and it seems to me that incrementally cost-wise, it's to everybody's advantage to hit these areas that have the greatest impact as quickly as we can, because you don't know when the next flood or rain situation is going to occur. Um, and I was wondering on Coach Street, specifically when who's now out of business, um, designed the storm drain. They did, and I walked them underground, the 90-degree angles that I think there were three or four in a 300-foot space when it crosses from one path down coach to the next. Uh, and that mitigated against the water flow. Is there any consideration? Have your engineers looked at that? Are they thinking of looking at that? As far as how can you straighten out that flow when you have 90-degree walls? There were like three or four walls that the water would go up again and have to turn 90 degrees. And then 60 feet further, they had to turn another 90 degrees. And 60 feet further, another 90 degrees. So I'd like to know if you can comment on that. And the second thing is, understanding that some of these things might be uh, tough for the county to approve, um, the council to approve. I'm sure you guys will get in the optimal, but that doesn't mean the council, who's political, is going to approve it. And my thought is, what is it that we can do that incrementally, I'm not talking about a Band-Aid, incrementally to get it started, to get some relief, to get a possibility of the major flood not being as major as it was that we went through? Is there is there any mitigation, anything that can be done within budgets that are active budgets that they can create? I know there's funding, there's a great need for funding, but at the same time there's funding, and the question is, can you get a hold of some of those funds, and how much are some of those funds? And I'm saying, suppose we get to suppose you find a way to get those sidewalks lowered. Maybe that's $1 million or 1.2 or 2.4 or something. And they can find funds for that. And yet they can't find funds for other parts of your plan. Is there a way we can do proportional, just do incremental improvements to this thing without waiting,
Sure.
like you said, 2026? And then who knows if that gets through and improved
Well,
and that.
let me take a stab at that. Thank you for a great comment. So I think two things I heard from you. So the uh, the zigzagging again of the existing storm drain system, it definitely causes it's an inefficiency. Just in general, that is uh, uh, basically the way subdivisions have been built for many years. Is there was a natural stream, as Matt had mentioned, and then you come and put a road grid over top of it and houses, and so then you get a zigzaggy etch-a-sketch thing that has inefficiencies. So we're definitely going to look at improving those inefficiencies by whether is it a parallel pipe, a larger pipe, or something like that. And there can definitely be a phased approach to it too, as you mentioned on the budget. Um, some of those incremental approaches have already been done. Matt mentioned two of them that happened in the neighborhood already through the existing storm drain program, but that is very limited funds and it covers the entire county. That's why we have the bigger budget for this neighborhood, and that our cost estimates that we take to the council, and it might be incremental. Like it could be a phase one, like let's get the lowest hanging fruit, as you mentioned. Maybe it's lower the sidewalks for a certain amount, and then you can't afford to do larger pipes until a couple years later. But it would be, we can address those strategies depending on what we come up with, the estimates for each of the individual fixes. And then another part of the incremental part would be the bioswales and the bioretentions in the upper parts of the drainage area to, again, just slow down a flood, make it take longer to flow through the system. So all of those things can be presented to, if it's too expensive to do in 1 construction year, maybe it's spread over a couple of years or something like that. So that's a good approach to a larger budget, a phased approach. Thank you for that comment.
Okay, next we'll hear from Jeannie and Andy Tepper.
Oh, hi. I didn't have any specific questions right now, other than wanting to know the approximate timeline as far as when work would actually begin, assuming that all the political difficulties could be ironed out.
So again, we're going to work through the engineering design over the next year and a half. And so nothing would be done before that. There's a whole design and permitting process, and it would have to go through the budget approval. So no construction could occur prior to the summer of 2026. That would be FY27. So we're getting ready. That's the process we're going through here, is to prepare a budget for known either one project or a phase project, and what that would cost would be, and putting that in front of the council for approval.
Okay, so the best case scenario would be end of 2026 then.
Correct.
Okay, great. Thank you very much.
You're welcome.
Okay, next we have Jeff Gagliardi.
Hi, Jeff Gagliardi here. I have a couple specific questions regarding one location in this, and that is the storm drain inlet at 8105 Coach, our family homes at 8101 Coach. The mechanism of flooding that we saw at that location was water coming up out of the storm drain system during the flooding incident in 2019. And so the concern there is, I'm wondering if you've looked at this, not so much water runoff during a large storm. I don't think we've ever been concerned about that. What we are concerned about is that water's got to be flowing through the system, and it's going to run into a choke point either there or further downstream from that, and it's going to back up again at that location. And there's really nothing that we can do if it does back up at that location, come out of the storm drain and flood us. There's nothing really we can do short of building a 3-foot retaining wall up around the house, which is never going to happen. So have you looked at that? Is that a factor? Because it certainly seemed to be the cause of our flooding back in 2019. So I'm wondering what the thoughts are on that, and if you've looked at that. How is that going to be addressed?
Yeah, so that's going to be part of the kind of holistic design strategy, in that we'll be looking at, so I mean, the backup is essentially more water was coming to that inlet than it was able to escape through the pipe. So part of our strategy will be looking at the pipes. Can we increase the size of the pipes in particular locations where there's a bottleneck? Water retention, so trying to keep that water upstream of the issue held in bioretentions or swales or underground storage or something like that, and then slowly released over time so that the existing capacity at that inlet's not exceeded, or at least not exceeded as much. And then, if we do get the flooding, providing some kind of a overland flow mitigation, where if we cannot possibly get enough water through that system and we end up with a situation where you get the bottleneck or you get water coming up through the inlet and flooding on the street, it's got somewhere to go over the surface in a relatively safe manner, down to, eventually the stream at the end. So it's going to be, again, holistic strategy. We're going to be looking at all those things. All those things will contribute to making improving the capacity or retaining the water to try and prevent that from happening. Because yes, as you're alluding to, the issue would seem to be that the pipe capacity at that inlet's just not big enough. So, but we have a variety of ways that we can attempt to improve that situation, or at least protect you better during those floods.
And just to add on that, please give your contact information to Matt and the team, and we can meet specifically with you and talk about ideas there. Again, what you have seen, and even we, so we can be very specific about what is happening at that location.
Sure.
To come up with a strategy, and then even also maybe even think about, like you mentioned something, you said that's not going to happen, but maybe there is something that could be done on your private property to also.
But believe it or not, I've thought about putting, waterproof, almost like porthole on a ship, reinforced areas around the windows on the front of the house. I mean, it's that drastic. I can't think of any other thing that, other than eliminating windows at the front of the house at the basement.
Right. So again, we don't have to get into the details right here, but I think it would be great to have the team meet with you and maybe it is, again, it's like a combination of all these things could really help you, right? Like some on the private side, what we're trying to do on the public side, can go a long way.
Can I ask one follow-up question?
Sure.
So we've talked about sort of the planning and proposed budgeting timeline, et cetera, et cetera. What's the best case scenario for when work could actually be done and completed?
Again, so we're working on the design, the concept and the design over the next year and a half. No construction would start before that, but depending on the scope of it, this within a year or two, and that's all depending on the funding, right? Like,
sure.
And
I'm talking best case scenario.
And it could be staged too. Again, if it gets too expensive, and you say like, all right, we're going to try to address the biggest problem first, or whatever, step by step, and try to do that. Again, there's lots of things that can happen, and it's a little bit of a guess right now, like without knowing the solutions to say how long, but typically like a year of construction if everything was fully funded.
Okay.
Two, our construction projects are what, and it would be, again, it would be spotty, if you will, all over the neighborhood or all over the drainage system. So you would move. It wouldn't be 2 years at one spot. In other words, it's like
it'd all be going on at once if it was funded.
Yeah, but it wouldn't all be going on at once. Like it would be, the construction crews are limited. They kind of work in a series.
Okay. Thank you.
Thank you.
Okay, that's all I have, and it is 7:29. So
did we ever get Mr. Duncan? I think
Oh, Mr. Duncan, can you unmute yourself?
I think we had missed him earlier.
We did.
Well, Mr. Duncan, if you can hear me, if you have any questions or anything, you can send an email to lawyer, send it to me, or go to the River Falls website and go to the participate tab and put in the comment there. And then, like I said, we're working through everybody's individual comments. We want to get back to everybody. Like Dan said, if there's a very specific issue that you have that you want addressed, we can talk about it with you, potentially meet on site with the design team. All that's possible. So just let us know, and we'll try to get to everybody over the course of the design. So. All right. Well, if that's it, I just
want to say one thing. Somebody just typed a question about a report for its promise. The report has been completed. The analysis was done, and it's on the website. The link to the website where the initial report, which is
I've got it a couple places
that did the analysis of the system, which has led to this part. That report is available and on the website. I think Edward F asked that.
Let me see if we can, maybe I can put this in the comment section here.
You have there you go.
That's it there at the bottom. Let me see if I can
So the report is available there on the Montgomery County Department of Transportation, Division of Transportation Engineering. If you need that link to that, please just reach out to Matt or Lori, and they can give you that, and you can review the report. You're welcome.
Okay, well, thank you everybody for joining us this evening. If there aren't any more questions, I guess that brings us to the end of our meeting. Have a great night. And again, thank you for joining us.
Great. Thank you, everyone.
Yeah, thanks.